I'm Anil Kumar sharing with you a video to review quadratic equations when complex numbers are involved. Since it is January final exam for many of my students, I've been getting a lot of requests on this. So I thought of making a complete video which may run into half an hour. Okay, we'll discuss these topics. First, we'll discuss the domain of complex numbers. We'll introduce pure imaginary number iota or I. We'll see how to evaluate powers of I. Real and imaginary roots we'll discuss in brief. Solve quadratic binomial equations and trinomial equations with complex solutions and answer some communication questions, and then we'll write the quadratic equation from the given conjugate roots. I've also discussed this part in another video which you can go through. So let's begin by understanding the complex part, how it comes into quadratic equations. So let me take a general equation ax squared plus bx plus c equals to 0. Now to find solution, that is to find roots, so when we say solution, then we are basically finding roots, right? What do? We use this formula. X is equals to minus b plus minus square root of b square minus 4ac divided by 2a, right? So that's the formula we use. Depending on the value of the discriminant, this part is called discriminant. Normally you write d, which is this part, square root of b square minus 4ac. Well, at times we also write just b square minus 4ac, not the square root. So you know, if b square minus 4ac is greater than 0, then we have two real roots. Correct? If b square minus 4ac is equal to 0, we have one real root. Right? But if b square minus 4ac is negative, less than 0, we have no real root. Right? So we stopped here earlier. But since we have a quadratic equation, right? So 2. So if it's also a polynomial, right? So if we have polynomial, like we have a quadratic equation is a polynomial, right? Of degree n, then how many solutions do we have? Then we have n solutions. You should remember that part. So for this quadratic equation, how many solutions do we expect? We say no real root. But does it mean that it does not have any solution? That is what we are going to discuss. Well, it may not have solution in the domain of real numbers, but it does have solution in the domain of complex numbers, right? So we say it has two imaginary roots. So that brings us to the domain of complex numbers. Right? So that is a brief description that brings us to the domain of complex numbers. Where, how do we solve this problem? We solve this problem by letting square root of minus 1 to be equal to I, or square of a number to be negative. Perfect. And that is called a pure imaginary number, right? So just remember that I square, iota square is minus 1, or the square root of minus 1 is now equal to I, where I is a pure imaginary number. Is it okay? So that brings us to the domain of complex numbers. So as soon as we start having iota or I, we are moving from real to imaginary domain of numbers, right? So with that, let's move on to our video, which is discussing concepts on domain of complex numbers, right? So I've already discussed a part of it. Now here, I'll just elaborate it further. So let's take an example. If I have a quadratic equation, very simple, let's say x squared plus 4 equals to 0. Now as you can see, this equation, if I'm trying to plot it, what do I get? I get something like this, a parabola which moves upwards, correct? This is what I get. Here I have x-axis, y-axis, and this point when x is 0 is at 4. So in this particular case, there are no x-intercepts. That means no real solution. Is it okay? So that is what it is. Why there is no real solution? Because if I rearrange, I get x squared equals to minus 4. And what did we learn? In domain of real numbers, square is always positive. Do you see that? Never negative. Is that okay? Perfect. Right? In the domain of real numbers, square is always positive. You cannot have negative value. Right? And therefore we say that x equals to plus minus square root of minus 4 has no solution. Is that okay? But the story doesn't end here. So when I joined engineering, we started off with this and we found that there are numerous examples where we have to solve this equation and work with it. Electricity which comes in our homes and everything we deal with in electronics actually has solutions in complex domain. So how do we solve it? Solution is so simple. Innovative idea. We say, well, let some number squared be negative 1. That should solve the question, right? That also means the square root of negative 1 will now be iota, I. This is called pure imaginary number. Do you see that? So now if I consider square root of minus 1 is I could write this as x equals to plus minus square root of minus I. Let me rewrite this, right? So we could write plus minus square root of minus I is what? Minus 1 is what? I. So I could write I here and square root of 4 is 2. Do you see that? So normally I prefer to write this as plus minus 2i. So that becomes the solution. Correct? So that is the basic. Let's check it out. How will you check it? That this is the solution. Okay. So if I substitute in my equation 2i for x squared, so I write 2i whole square, let it be plus or minus plus 4. So that gives me 4i squared plus 4. Since we know I squared is negative 1, we get 4 times negative 1 plus 4, which is 0, and therefore it is the correct solution. Do you see that? So with that, I hope the concept is absolutely clear. Complex numbers really work to solve such questions, right? So our problem of square root with a negative number has been now resolved. Let's move on. Here is how we are going to explore further this imaginary number I and evaluate different values. Let me also introduce to you imaginary coordinate plane, right? It's a good idea to introduce it now. Here we have real numbers. Okay, so we say real along this axis, which used to be your x-axis, and this we'll call imaginary. So you can actually plot imaginary numbers on a coordinate plane. So if I have a number, let's say 2 plus 3i, it really means we'll go 2 along the real axis, so 1, 2, and 3 along imaginary, 1, 2, 3. So this point here represents 2 plus 3i. Do you see that? Similarly, I could have some other point. For example, if I have a point which is, let us say, let's say 1 minus I. Okay. Now 1 minus I means that I go 1 unit and 1 negative. That is the point. Is it okay? So let me call this point as B. Then this point is B for you. Do you see that? 1 minus I. So in this coordinate plane, where one axis is real, the other one is imaginary, I can plot any complex number. Is it okay? And of course, this origin remains origin O. Sometimes we do polar coordinates and call it a pole. We'll get into that also, but not in this video. Okay. Now let's evaluate what is I cube, what is I to the power of 9, I to the power of 16, I to the power of 26, and so on. Well, what we know here is I cube will be I times I times I. Is it okay? Now what is I times I? Which is I square, right? I square times I. I square is -1, so we get negative y. Do you see that? So we are working with basics, that is I square is -1, and as you know, -1 square root is I. Perfect. So we get our answer. If I have to figure out what is I to the power of 9, I have a different way. So what you will notice here is that on this plane, here we have, let's say, 1, right? So let's say this is 1. Then this is what? This is I. And this is actually -1, which could be written as I square also. And you just found that I cube is minus I. So this means this is minus I, correct? And what will be I to the power of 4? I to the power of 4 will be 1, right? So what we notice here is that as you multiply by I, it keeps on moving, right? So what is I to the power of 4? It is I square times I square, which is -1 times -1, which is +1. So you get back to where you started. So what you notice here is that we could evaluate powers of I as this is I to the power of 0. This becomes I to the power of 1. This becomes I to the power of 2. This becomes I to the power of 3. This becomes I to the power of 4 and 5 and so on. So the circle continues. To find I to the power of 9, I'll use this circle. 0 is here, right? So it is 1. So we say 1, 9. We have to go to, right? So it's 1, 0, right? 0. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So it should be I. Do you see that? 16. 1, 2, 3, 4, 8, 12, 16. So it should be number 1. And 26. What do we do here? We actually divide 26 by 4. What do we get? 4 times 6 is 24, remainder is 2. So we get this as equals to I square, which should be -1. You get an idea. That is how we could evaluate any power of I. Okay, so I hope the concept is clear. That should help you to find solution to I to the power of n, right? Let's move on to the next example now. So here's another very interesting question. We need to find the coefficients a and b if 2 minus I times a plus bi equals to 10 plus 15i. So let me rewrite this question here. 2 minus I times a plus bi is equal to 10 plus 5i, right? We need to find value of a and b. To solve this, we'll apply the distributive property, right? We'll apply the distributive property and simplify. So basically, we'll multiply with 2 first, both these components, and then with iota. What do we get? So 2 times a is 2a, 2 times bi is plus 2bi. With minus ai, we get minus ai, and we get minus bi squared, right? So that's what we get from the left side. So we are working on the left side. And this should be equal to 10 plus 5i, correct? Let's simplify this part. So we have 2a plus 2bi minus ai. What is I square? I square is negative 1. So we could write this as b times negative 1. And then we could write this as 2a plus 2bi minus ai. Negative negative becomes positive b, and we could now write this as 2a plus b, let's rearrange, right, plus 2bi minus ai. What do you notice here? You notice that we have a real part, this is the real part, and that is the imaginary part, correct? So I could write this as 2a plus b and factor out I to get me 2b minus a. Does it make sense to you? Perfect. Now as you can see, all this is equals to 10 plus 5i, correct? All this is equals to 10 plus 5i. So real part should be real part. So all this is equal to, we can write this is equals to 10 plus 5i. Now that gives us two equations. One of them is 2a plus b equals to 10. The other one is 2b minus a equals to 5. Does it make sense to you? Correct? Just comparing. So what we have done here is we have equated this part to the imaginary part and that part to the real part. To get these two equations, let me number them as equation 1 and 2. Now we'll solve these equations. Is it okay? We'll solve these equations to find both a and b. So we have 2a plus b equals to 10. Let me rearrange. So we have minus a plus 2b equals to 5. So if I multiply the second equation by 2, that is to say, if I multiply this equation by 2, what do I get? I get minus 2a plus 4b equals to 10. Correct? I get minus 2a plus 4b equals to 10. So now let's consider our equation number 1. This was 2. Let me call this as 3. So if I add them up, so if I add equation 1 with equation 3, what will I get? So 2a minus 2a is 0, right? And b plus 4b is 5b. And 10 plus 10 is 20. 10 plus 10 is 20. So we get b as equals to 20 over 5, which is 4. Since you know what b is, now you can use one of the equations. So we have 2a plus 4 equals to 10. 2a equals to 10 minus 4, which is 6. A is equals to 6 divided by 2, which is 3. Correct? So we get our answer, and that is a equals to 3 and b equals to 4. Perfect. So a plus bi, that means a plus bi is actually equals to 3 plus 4i. Correct? So what you can do is you can use 3 plus 4i, multiply with 2 minus I, and verify if we have the right answer. I hope you're finding it interesting. Let's move on to the next question. Now we'll solve quadratic binomials involving I. Involving I really means in this solution, right? I in solution. Is it okay? We'll also take up quadratic equations where I will be involved in one of the terms, right? Okay. So we have x squared plus 16 equals to 0. That should be very simple. You could do it like this: x squared equals to minus 16, x equals to minus 16 square root. Whenever you do square root, don't forget to write plus and minus. Square root of negative number, you know, is I, so we get plus and minus I. Square root of 16, square root of 16 is 4, so we get plus minus 4i. That is correct, right? So that's the solution. You could check this solution. Substituting 4i here, square plus 16, that gives you 16i square plus 16. That gives you minus 16 plus 16, which is indeed 0. Simple check. Let's do the next one, which is x squared plus 20 equals to 0. So I'll write this as x squared equals to minus 20, x equals to plus minus square root of minus 20. Now as soon as I write this, now you know minus comes like this. Here 20 could be written as 4 times 5, square root of 4 is 2. So I'll write plus minus 2i square root of 5. So the solution here is plus minus 2i, square root of 5. Okay? These two questions are for you to do. Figure out their solutions, right? And let's move on to the next part. Let's solve a trinomial. We have two equations here. The first one is x squared plus 2x plus 3 equals to 0. I'll straight away use the quadratic formula, which is x equals to minus b plus minus square root of b square minus 4ac divided by 2a, when we have an equation which is ax squared plus bx plus c equals to 0. Correct? In our case, what is b? b is 2. So we'll write this as minus 2 plus minus square root of 2 squared minus 4 times a is 1, c is 3. Divided by 2 times 1, correct? So that gives us minus 2 plus minus square root of 4 minus 4 times 3 is 12. Divided by 2. Let's continue. We have minus 2 plus minus square root of minus 4 minus 12 is minus 8. Divided by 2. Now complex number square root of minus 1 is iota. So we could write this as I here. And 8 could be written as 4 times 2, right? 8. So what do we get? So from here we get minus 2 plus minus. Square root of 4 is 2. So we get 2i square root of 2 divided by 2. You can divide both of them by 2. So get minus 1 plus minus 2i. Is it okay? So 2 square root 2i, I'm sorry. So plus minus square root 2i. So that becomes the solution of the first equation. Is it okay? So let me rewrite this solution here. So we have solution of a is minus 1. Always we get two roots. These are called the conjugate roots, correct? So you could write I square root 2, or you could write minus 1 plus minus square root 2 I outside the square root. either way. So that becomes the solution for this one. And plus minus means there are two roots, right? Conjugate roots. Okay, let's do the next one here. To do the next one, we should rearrange. So we should write this as 2x squared minus 4x plus 3 equals to 0. So x is equals to 4 plus minus square root of minus 4 squared minus 4 times AC, which is 2 and 3, divided by 2 times 2. This is 4 plus minus square root of 16. 4 times 3 is 12. 12 times 2 is 24. So minus 24 divided by 4. That is 4 plus minus 16 minus 24 is again 8. Okay, 4 and 4. Okay, square root of minus 8 again. Simple, similar to what we did earlier. So I need not show you that detailed calculations. I can write this as 4 plus minus 2i square root 2, right? 4 times 2 is 8 divided by 4. So it gives me 1 plus minus 2 divided by 4 is half. Okay, so I could write this as half, right? And then see, I square root 2. In fact, this is a better answer to write. Is it okay? Sometimes you may write this as 1 plus minus I over square root 2. But preferred answer is 1 plus minus, as I have written, square root 2 over 2i. Since we want to rationalize the denominator, we do not put square root 2 in the denominator. That's the whole idea, but either one of them is correct. Fine. Let's move on. Some more examples, and this one is with real imaginary part in the equation. So pause the video for the time being. Try to solve this question. Now the coefficient of x is I, the imaginary number. Find the solution of this equation. I hope you're finding this series interesting, and I hope you must have got the solution for this one also. Now if you compare, what do we have? We have A as 1, we have B as I, and C as 2. So x is equals to, the formula is minus b plus minus square root of b square minus 4ac divided by 2a. So in our case, b is iota. So we write this as minus I plus minus square root of I square minus 4. A is 1, C is 2. Divided by 2 times A, which is 1. So what you get here is minus iota plus minus square root of, now I square is minus 1. So minus 1 minus 4 times 2 is 8 divided by 2. Do you see? And this could be written as minus I plus minus square root of minus 9 divided by 2, right? Let's take it to the right side and further simplify. So we have x as equals to minus I plus minus square root of minus 9 over 2. Square root of minus I is 3i, right? 3i. Since square root of minus 1 is iota, divide by 2. And that gives you 3i minus I is 2i. 2i divided by 2. I should have written plus minus. And 2 divided by 2 is 1. So we get plus minus I. Does it make sense? 2i divided by 2 is iota. So we get that as our solution, right? So can you check if this is the right solution? Let us check it. So we have x squared, that means I squared, plus I times I plus 2 equals to 0. I square is minus 1. This is also I square minus 1 plus 2 equals to 0. And so we get 0 equals to 0. Do you see that? So that is a very interesting question. You could have imaginary number as a coefficient in a quadratic equation, correct? So that's a unique example. I hope you appreciate it. Let's move on with some very basic questions now. So these are communication questions which you might get in your test. The question is, why square root of minus 3 times square root of minus 5 is not equals to 15 square root? Well, some persons can do like this, right? Square root of minus 3 times square root of minus 5, which should be equal to square root of plus 15. Well, that is incorrect. Why? That is the question. So this method of multiplying radicals is only when we're talking about any radical function x where x belongs to real numbers and x is greater than equal to 0. It cannot be negative. Okay, that is what it is. If you remember the square root function, if you sketch it, how do you get it? It is like this, correct? It is like this. The domain is always positive numbers. So truly speaking, I should have written minus 3 times minus 5, minus 5 as equal to I times square root 3 times I times square root 5. Does it make sense to you? I times I is I square. And then you can multiply these two to get 15 within the square root. And I square is negative 1. So that is your true answer. So this is not equal to this, but this is equal to negative square root 15. Perfect? Okay. So that's what we learn. One more question in communication series, which is show that plus minus 3i are the roots of this equation. So what you can do is you can substitute plus minus 3i for x. So the equation is x squared plus 9. So you could write this as plus minus 3i whole square plus 9. Evaluate. What do we get? We get 9i square plus 9, which is minus 9 plus 9, which is 0. So equation is true, correct? So therefore it is indeed correct solution, right? Perfect. So I think now we have one more question to go. Last question for us, which is another test question. Find quadratic equation from given conjugate roots. 3 different methods, part 2. So I have another video where I'm discussing 3 different methods to solve the same question. Well, here we'll do the shortest method. Roots are plus minus 7i. We need to find quadratic equation. So it's very different. Reverse, right? So we are doing the reverse thing. Working backwards. Does it make sense? We're given the roots, find the equation. That is what it means. If the equation is having a root at plus minus 7i, it means I could write this as x minus 7i times x plus 7i, correct? That's what it means. And that is x squared minus 7i squared, and that means x squared plus 49. To make it an equation, I'll equate this to 0. Do you see that? 0 equals to this. So my equation is x squared plus 49 equals to 0. That's the solution. The second one here is roots are very complicated. Wow, how to do this part? Well, the roots means x is equals to this. But if my equation is ax squared plus bx plus c equals to 0, x is equals to minus b plus minus square root of b squared minus 4ac divided by 2a. Do you get a hint from here? Compare. That's the hint. So if you correlate these two, what do you get? Well, let's do it. So let's do that part first. That's simple. So 2a is 2. So we get 2a equals to 2. So a is equals to 1. That's simple. How about b? Okay, let's compare this part, which is second box. Isn't that interesting? So we have minus b equals to 3, b equals to minus 3. Simple as that. How do you get c? You got it. C is simple. Just compare within the radical sign. Oh, what about this I? So we need to rewrite this. Is that okay? So rewrite space. Let's rewrite first. So let me rewrite this. I'm writing as 3 plus minus. Taking I inside the square root makes it minus 11 over 2. Now can I compare? That's brilliant, right? So now we'll compare this. Does it make sense? To get the equation, you can pause the video, do it yourself. So we have b squared minus 4ac equals to minus 11. Since it is negative, we have complex roots like this. Okay, b is minus 3, so it's minus 3 squared. Minus 4 times a is 1. C we don't know, we'll find it. 9 minus 4c equals to minus 11. Okay, so 4c equals to, bringing it here, 9 plus 11, which is 20. So c equals to 20 over 4, which is 5. Okay, so we get our equation, right? Equation is of the form of ax squared plus bx plus c. That is the equation. Okay, so what is a? A is 1. So we get x squared, b is minus 3, minus 3x plus c. C is 5 equal to 0. So that's the end of this video. I hope you found all types of questions here. If not, feel free to make suggestions so that I can add in the next part. Feel free to share my videos, and if you like, that'll be great. Subscribe and post questions. Thank you for your time and all the best.